Hello and welcome to my video Introduction to BGP Configuration. In this video I'll demonstrate the configuration of both eBGP and iBGP peers as well as route advertisements between a multi-autonomous system network. Now let's take a look at the lab I'm going to be demonstrating, and in this lab let's take a look at the lab that I'm going to demonstrate. In this lab, we're going to have to create an iBGP full mesh environment in Autonomous System 1. This includes creating a multi-hop link between R2 and R4. We're also going to have to create eBGP neighbors between R1 and R2, as well as R4 and R5. And at the end of it all, R1 should be able to ping 172.16.5.5. It's going to have to use a source address of 172.16.1.1 because R5 may not know about this address here, 192.168.12.1. So let's get started. But before we get started, I want to go over the BG commands that we'll be using. You can go ahead and pause the video if you want to write these down, but the first command we're going to do is we're going to turn on BGP. That command is router BGP, followed by the autonomous system number that the device will be in. The next command we're going to do is network, followed by the IP address, or the IP prefix, followed by mask, and then the subnet mask. That's the command used to advertise a network into BGP. Now to configure a BGP neighbor, we're going to have to do that statically, so we'll use the command neighbor, followed by the IP address, followed by the remote AS and the AS number. And if we want to use BGP to configure a loopback address for BGP updates, the command is neighbor followed by the neighbor IP address, and then the command update source loopback followed by the loopback number. And let's take a look at that command. So right now we have R2 getting ready to send an update to R4, and it's going to send the update to IP address 4.4.4.4, but the source IP will be the egress interface of R2, or E01. And when it sends that to R4, R4 is going to receive that, and it's going to look at its BGP neighbors table and say, I don't have a neighbor relationship with 192.168.23.1, so I'm going to ignore that. So using the update source loopback 0 will force R2 to use 2.2.2.2 when it does its BGP updates. And the last command we're going to use is neighbor IP address followed by next hop self. And this is used to require an iBGP router to update the next hop field for iBGP updates. If you remember, iBGP does not update the next hop field, but there is sometimes a need for that to happen, especially with border routers. So in this scenario, router 2 is going to receive an update from router 1 with the network ID of 172.16.1.0 and the next hop address of 192.168.12.1. And R1 is happy to receive that, and it knows how to get to 192.168.12.1, so it'll put it in its routing table, and it'll be able to reach that address. But when it sends that update to router 3 is going to look at that and say, I don't know anything about the next hop of 192.168.12.1. I can't reach that address. So by telling R2, or my border routers, to update the next hop address to themselves, this will allow our iBGP routers to receive updates from other autonomous systems. So the last set of commands I want to look at are some BGP show commands. If you want to do the command, if you want to view your BGP neighbors, the command is show IP BGP summary, and the last command we'll be demonstrating will be show IP BGP, and that's what we'll use to view our BGP routing table. In the lab scenario, I've already configured OSPF between routers 2, 3, and 4. And I went ahead and confirmed that, and router 2 can indeed see the loopback of router 3, as well as the loopback of router 4. And then I went ahead, and just for good measure, I went ahead and pinged both of those addresses, 3.3.3.3 and 4.4.4.4. I also went to router 1, and I confirmed that I can indeed ping router 2. And from router 5, I confirmed that I can ping router 4. So let's get started with the iBGP configurations within Autonomous System 1. So I'm going to go into router 2. I'll start there and just work my way across. Router BGP 1. And I'm going to configure a neighbor. And I'm going to use the loopback addresses for my neighbors because those are always going to be available you never really know. If you lose a link, you don't want to have a neighbor going to a link that's down. So my neighbor will be 3.3.3.3 remote AS1. And then I'll go ahead and create another neighbor to 4.4.4.4. And that's great, but these neighbors aren't going to come up because, like we said before, my link between R2, it's going to use that source address of 23.1. So I better do the neighbor 4.4.4.4, then update. Loopback 0. I'm going to add the update, and then I'll go ahead and do the same thing for my neighbor with router 3. I don't need any network statements with this because I'm not going to be advertising any local networks or loopbacks through this through AS1. So that looks like I've got the configuration for router 2 done, and I want to show you something. Show iBGP summary. I can see my neighbor table. Don't let this confuse you. With OSPF, you'll see neighbors only after you've started communication with another peer. With BGP, these are static neighbors, so you will see these neighbors as soon as you configure the neighbor statement. What you need to pay attention to is messages received, messages sent, and you also want to pay attention to the state. It's in the idle state. It's not doing any thing, and you have not received any prefixes through this autonomous system from this neighbor. So even though this shows up in the neighbor table, we don't really have a neighbor yet. So let's go on to R2 and fix that. So now with router 2, same commands, P1, neighbor, 2.2.2.2, remote, AS1, and I'll do neighbor, and I'll do the update here. And then I'll do the same thing for router 4. And that's not going to like that. I need to do the neighbor first. So let me change my neighbor to 4.4.4.4. I have to create the neighbor before I can do the update source loopback 0. So I've created the neighbor on R3. Let's go into R4, create that, and then we'll take a look and make sure we have our BGP neighbors established. Router BGP1, 3.3.3.3, and I may as well create the neighbor for 2.2.2.2. Now I can go ahead and do the update. And I'll do the same thing for our router 3. So I've added the neighbor statement and the update source loopback 0 for both devices. Now let me see if I get my BGP neighbors established. I do not yet have neighbors. BGP can take a couple of minutes to converge. Let's see if router 2 has a neighbor yet. Let's see BGP sum for my neighbors. So router 2 now has the neighbors, and look, they're up. They've been up for about a minute now, and we have not received any prefixes, but we're not advertising prefixes yet. And I can go ahead and look at router 3 and do the same thing. Show iBGP sum, and that's my neighbor table, and those neighbors are up on router 3. And just for good measure, we can look at router 4. Show iBGP sum, shows my neighbors table. And I have my full neighbors between all 3 routers in my autonomous system. So let's go ahead and start building some of these eBGP pairs. So I'm going to go to router 2, and I will do router BGP1. And now I'm going to configure a neighbor, and I'm not going to use a loopback because this loopback is from another autonomous system, another organization, and there's really only one path to this router across this link, so there's really no need to use a loopback. In iBGP, we could have multiple paths to get to these devices, but with eBGP, there's really only one hop. So my neighbor is going to be 192.168.12.1. 192.168.12.1. And then a remote AS. AS will be 3. That's all I need to do on router 2. I don't need to do an update source loopback 0. Actually, if I did that, that would screw things up. And then on router 1, I'll go to the other end. BGP, and this is an autonomous system 3. And my neighbor will be 192.168.12.2. AS will be 1. And let's give that. And now in autonomous system 3, we're going to advertise that loopback 1 address. So we have to do the network statement. Network 172.16.1.0. Mask will be 255.255.255.0. So now we've actually should have an eBGP peering relationship between R1 and R2, and R2 should start seeing those routes. So let's take a look at R2. And I am indeed receiving the route 172.16.1.0 with the next hop of 192.168.12.1. And that's great for R2, but we need to make sure that R2 is going to update the next hop field when it forwards that route to R3. So let's go back into R2 and make sure that it does that. GP1, neighbor is 3.3.3.3, and the command for updating the next hop will be next hop self. And that will ensure that when we send an update to router 3 that we update the next hop field, and then we can do the same command for our peering relationship with R4. So now let's go into R4, and we're going to have the same problem in R4, so I may as well fix those neighbor relationships as well. Neighbor 2.2.2.2, next hop self, and I'll do the same for R4 to R3. And we've updated the next hop self, next hop there as well. So now let's go to R5 and configure R5 for eBGP. And this is an autonomous system 2. 192.168.45.4 remote AS1. And then we need to do the network command. So network 172.16.5.0 mask 255.255.255.0. So now router 5 should be advertising to R4 that network ID. I can't remember, did I configure the neighbor? I did not configure the neighbor on R4 yet. So let's create the eBGP neighbor on R4. And the neighbor will be 192.168.45.5 remote. AS will be 2. So now let's look at our show IP BGP sum and see if we have that neighbor. And it's idle, it's not quite up. 192.168.45 is an AS2. So let's look at R5. Maybe it's just taking a second. And neighbor is an AS1. And I did receive a prefix, so it looks like that neighbor came up. Let's look at R4 again and just double check that. BGP can kind of be slow. And I do indeed have the neighbor established. It's been up for 23 seconds and it's received a prefix. So now let's take a look and just do some confirmation. Okay, so now that we've configured BGP, let's go ahead and test it. So before I even try to ping, I want to just take a look at my BGP routing table in R1. So I'm going to do show IP BGP, and I do indeed confirm that I do have the path to 172.16.50, and the AS path I will go from, starts at AS1, then it goes to AS2, and then from AS2 it's internal. So let me try that ping. 172.16.5.5. Now remember, I have to use the source address of loopback 1 because router 5 doesn't know about this address right here, 192.168.12.0. And I indeed successfully pinged router 5 across my BGP network. I hope you found this video helpful. If you did, please remember to like and subscribe, and thanks for watching.